What's up, everybody? Mr. Babbitt here, going to make a quick video for the 11.1 notes, simplifying rational expressions. So a little review here. When it says to factor, what we're looking for is first a greatest common factor. That's the first thing. And then depending on how many terms we have some different strategies. 2 terms, usually just a GCF, but you can also have difference of squares, sum of cubes, and difference of cubes. We won't really be dealing with these two today. With 3 terms, you're going to do a T-chart, and then with 4 terms, factor by grouping. So this first one, if we look here, we can see that it has a GCF of 6, and we can also take out an x squared. So when we factor that out here, the first term becomes x, and the second term is going to become 5. Because when you divide that out, you're left with an x. 30 divided by 6 is 5, and then the x squareds cancel as well. All right, so that's what we got there. If we look at the second one right here, it has 3 terms. So when we have 3 terms, we're going to do a T-chart like this. Over here on the left is going to be x, and then on the right you'll have a positive 9 and a positive 7. When you cross multiply here, you'll see that you'll get 16x. So your answer is just x plus 9 and x plus 7. All right. This next one, we look for a GCF first. We don't see anything, but we do have a difference of squares, right? 16 is a perfect square, and so is 49. So you can do 4x and 4x, and then a positive 7 and a negative 7. When you cross cancel here, or cross multiply, the b term will cancel out, which is exactly what we want. So we got 4x plus 7, 4x minus 7 as our answer there. And then whenever there's 4 terms, you're going to do factor by grouping. So we take the GCF of the first two, which is 5x squared, and then divide this out. You're going to get left with 3x minus 1. And then if you look at the second set of numbers here, since this first part is negative, we're going to take out a negative 3, and you're going to get left with 3x minus 1. And you can see that these two match, which needs to happen. So your answer is 5x squared minus 3, and then 3x minus 1. All right. Now, that's just a little warm-up getting us ready for this. We are going to simplify rational functions, which is a function that can be written in the form of a fraction with 2 polynomials. So you see some examples down here. All right. What we're looking for here is what we call excluded values. What excluded values are the values that make the denominator equal to 0. Okay. The reason that this is an excluded value is that if you have something like 4 over 0, when you have the 0 on the bottom of your fraction, this becomes undefined. All right. So we're figuring out what values make our rational functions undefined. So all we're going to do here is we're just going to take our denominator and we're going to set it equal to 0. All right, so we get minus 2 on both sides. X equals negative 2, but it in fact cannot equal negative 2 because that's our excluded value. Because if we plug that back into our equation here, it'll make the denominator 0. All right. Now, this next problem, problem B, it has 2 parts, right? It has this x and it has the x minus 2. So we're just going to set each individual part equal to 0. So this one we don't have to do any work. It's just x equals 0. And then this side over here, we got x minus 2 equals 0. So you got plus 2, and you get x equals 2. Again, excluded values. So x cannot equal 0 and x cannot equal 2. All right. Looking up here, again, we're just looking at the denominator for now. Since it's 3 terms, we look for a GCF, nothing there. So we're going to do a T-chart. You're going to get x, and then to multiply to 10, I'm thinking a positive 5, positive 2. When you cross multiply there, you are going to get 7x. So this bottom part becomes x plus 5 and x plus 2. And then to find our excluded values, we're just going to set each of those equal to 0. So we got x plus 5 equals 0, minus 5, you'll get x cannot equal -5. And then over here, x plus 2 equals 0. And you'll get x cannot equal -2. So these right here would be our excluded values. All right. Same thing down here, but we'll talk more about that on the back page. Okay. Back here, we have simplify each expression. All right. So what this is saying over here is that C, we have a C on top and we have a C on the bottom. If you have one of each on the top and the bottom, those can reduce out, and then you can get left with A over B. Now, before we reduce anything, this is the major thing right here. It says state the excluded values before simplifying. So before canceling anything out, we're going to have to find our excluded values. All right. So when we look up top here, these are both negative. I can factor out a -1. And what I'm going to be left with is x plus 4. And then on the bottom of my fraction, I have 3 terms. When I have 3 terms, I'm going to do a t-chart. So I'm going to have x and x. A -8 means that I'm going to have a 4 and a 2. And if I make the 4 positive and the 2 negative, that'll give me the 2x that I'm looking for down below. So now I can rewrite that under my fraction here. I got x plus 4 and x minus 2. All right. Now for our excluded values, I'll do those down here where I have some more room. You're just going to take each of these and set them equal to 0. So I have x plus 4 equals 0 and x minus 2 equals 0. So -4 minus 4. X cannot equal -4. And then plus 2 and plus 2. X cannot equal 2. So those are going to be our excluded values. That'll come more into play when we get into some solving. Now we turn our attention back up here to our expression, and now that we've written down our excluded values, we can start canceling some things out. X plus 4 on the top and bottom cancel out, and so you're left with -1 on top, and then x minus 2 on the bottom, and then our excluded values down there. All right, let's take a look at the next one. I'll leave that up there in case you want to look. So same thing over here on this right side. We can factor out a -3 from the top, and that'll give us 1 plus x. And then on the bottom, we look for a GCF. Not seeing one, but with 3 terms, we can do a t-chart. We want it to add up to -6x when we cross multiply, and we got x and x. It looks like -7 and +1. All right, so now I can rewrite that x minus 7, x plus 1 right there. Now, again, before I start canceling some things out, I must do my excluded values. So what I'm going to do is I'm going to take these 2 sets of parentheses, these 2 binomials, and I'm going to set them equal to 0. So x minus 7 equals 0, and x plus 1 equals 0. So plus 7, x cannot equal 7, minus 1, x cannot equal -1 there. All right, now that we've done that, we can cancel some things out. We got x plus 1 and 1 plus x. Those are the same thing, just written a little different. And so you're going to get left with -3 over x minus 7 like that. All right, and then, of course, our excluded values there. All right. Same process down below. We're not going to do all of these, but I will show you maybe 1 or 2 more here. These ones are both just going to be t-charts. What you can do is you can we won't do this one, so you can use the room down here. We're going to factor the top of this. So we get 2x squared minus 7x minus 4. Whenever you have 3 terms, first you look for a GCF, but there isn't one. And then you're going to do a t-chart. So it's looking like 2x and x. And then I think maybe a -4 down here and a +1 there. All right, when you cross multiply, -8 and +1 gives you the -7 that you're looking for. And so now that's going to be the top of your fraction. So we'll say 2x plus 1 and x minus 4. All right, and then I'm going to take this equation here, and I'm going to write it over here where I have some more room. 10x squared plus 7x plus 1. And then I'm going to do a t-chart here as well. So 5x and 2x. And then I think it looks like, since it just needs to add multiply to positive 1, it's just going to be plus 1 plus 1. 5x, 2x, positive 7x, so we're good there. And so now I'm going to write this down on the bottom part of my fraction down here. So I got 5x plus 1 and 2x plus 1 like that. All right, now before I can cancel anything out, I need to do my excluded values. And my excluded values, I set each of these things equal, each of the denominators equal to 0. So I got 5x plus 1 equals 0, and 2x plus 1 equals 0. Couple more steps this time. Actually, just one more, I guess. To get x by itself, you'll divide by 5 here, and you'll get x cannot equal negative 1/5. And then same process over here. 2x equals negative 1, divide by 2, and you get x cannot equal negative 1/2. So there's your excluded values. Now that we've done that, we look back up at our expression here. 2x plus 1, 2x plus 1 cancel out, and you'll get x minus 4 on top, and on the bottom, 5x plus 1. And that's going to be your expression there. All right. All right, one more. How about we take a look at this one down here. So again, we're going to have to factor both the top and the bottom. If we rewrite this top one, x squared minus 9. Two terms here, we look for a GCF, nothing. We have a 1 in front, that's a perfect square, and a 9's a perfect square, so we do have the difference of squares. So we got x and x, a positive 3 and a negative 3. That's going to work out for us nicely. So on the top of our fraction, we'll have x plus 3, x minus 3. And then on the bottom, we're going to look for a GCF here. It's looking like I can take out a 2 and an x. And when I factor that out, I'll get x minus 3. So the GCF was 2x, x minus 3 here. Before we cancel out excluded values, so we set each of these things equal to 0. So 2x equals 0, and x minus 3 equals 0. So divide by 2, divide by 2. X cannot equal 0. Plus 3, plus 3. X cannot equal 3. And then lastly, just cross off these because they cancel out. And your final answer here is x plus 3 over 2x. All right, so reminders, factor it, and then before you cancel anything out, make sure you write down your excluded values down here. Keep it organized so you can see where you're working. And then go ahead and cancel things out like we did up top and rewrite your answer there. All right.